Hi, this is Harry. This is the first in a four-part series answering the question, what is science? So we'll be using the items of the Nature of Science quiz developed by Larry Flamer. So make sure you've done that quiz before you start watching this film. So, what is science and where did science come from? The word itself comes from the Latin scientia, which means knowledge. So whilst Aristotle defined science as the body of reliable knowledge itself, of the type that can be logically and rationally explained, the modern definition is slightly different. So to Aristotle, science was any reliable knowledge, and it didn't matter how it was derived. In fact, Aristotle used logic and reasoning as his main tools. Back then, science and philosophy, two quite distinct fields today, are used interchangeably. Over the 19th century, science became increasingly associated with the scientific method, and experimentation became a key defining element, and this is the definition that we'll be adopting. So today we'll define science as the process by which knowledge about the natural universe is gained and seeks to move towards a more accurate, precise, and in-depth understanding of the universe and the stuff in it. So let's begin by looking at these 5 items of the Nature of Science quiz. So while certainly science has given us the airplane, the iPhone, antibiotics, modern agriculture, great big telescopes, satellites and cars, the primary purpose of science is actually to develop knowledge which is durable with ever-increasing comprehensiveness, precision and certainty. So you can essentially say that science is the search for truth. However, this definition is problematic. For some, the revealed truth of God or other deity or authority is considered to be absolute, final, and always correct, regardless of observations or study that may suggest alternative explanations. So this point raises important questions about scientific knowledge and how it differs from other types of knowledge. Scientific knowledge is never considered to be absolute, final, or always correct. It can always be overturned by new discoveries. So in this sense, scientific knowledge is always considered to be tentative. So for example, Aristotle and Ptolemy both believed that the Earth was the center of the universe and used epicycles and even more complicated epicycles to explain the motion of their heavenly bodies. Such was the reputation of Aristotle and Ptolemy that this view held sway for almost 2,000 years and no one challenged them. As an aside, a sun-centered model was proposed by Aristarchus of Samos around 200 BC, but that's beside the point. It wasn't until the 16th century did Polish astronomer Copernicus propose that the sun was at the center of the universe, with the planets orbiting in perfect circles. This was close, but not quite correct. Building upon Copernicus's idea, Kepler, using another famous astronomer's data, Tycho Brahe, went on to propose his 3 laws of planetary motion, one of which is that all the planets orbit in ellipses, and this made the sun the focus of one of those ellipses. Crucial evidence for the Copernican model of the solar system was provided by Galileo and later built upon by Newton, who demonstrated the laws that govern the heavens also govern the motion of the objects on Earth. The rules that apply in outer space also apply here on Earth and everywhere else in the universe. So in terms of astronomy, durable scientific knowledge could be considered that the sun orbits the sun in ellipses. The sun is one of billions of stars in the Milky Way, and the Milky Way is one of hundreds of billions in the universe. So the take-home message from this section is that science is concerned with understanding reality and as a consequence generates knowledge and leads to invention of new devices, that the authority of the person doesn't matter. That's what the knowledge says. That science is self-correcting, that wrong ideas are eventually discarded. For more information, you can look up the development of the atomic theory. Scientific knowledge applies everywhere in the universe, at all scales and for all times. That scientific knowledge has universality, and that scientific knowledge is cumulative and seeks to be more comprehensive, more accurate, and more precise over time. And here's a message from Professor Stephen Hawking.